Greetings and welcome to Make Programming Fun Again. This video is not sponsored. I'm just going to talk about this device, this cold wallet thing. And this story goes like this. So some time ago, a friend of mine wanted to buy a gift for his nephew, and he ended up buying him a cold wallet. And I asked him what type of cold wallet it was because I didn't really understand the idea behind cold wallets. So it turns out it's basically an equivalent of a piece of paper. This is this crypto steel thing. It's like a piece of metal where you can put metal rings. You can put metal rings on it and they just record your passphrase. And then you're still going to need a software wallet in order to use it. And I just thought, is there really no better way to do it? Like, do we really need this? And I thought maybe I can make a video where I can build a Franken wallet using KeePass and the Golang programming language. So this video is going to be a part of my Bitcoin series. Excuse my use of clickbait because nobody is watching my videos and I'm sad. So I decided to make a clickbaity video title and thumbnail. And without further ado, let's write some code. So the first thing we're going to need is we have to install KeePass XC. And if you use the downloader from here, then I think KeePass is going to be installed. I think KeePass is going to be installed in applications, right? So if we call applications KeePass XC, contents, macOS, KeePass XC. Okay, so this is my current installation. My current installation of KeePass XC comes from this from the official installer. So since we're going to be interfacing with KeePass XC CLI, we need to make sure where this thing is. Also, if you install KeePass XC using Homebrew, it's going to be available in the path, and then you don't need to do all this mental gymnastics in order to use KeePass XC. Also, if you are on FreeBSD or Linux and you install KeePass XC using your distro's package manager, then it's going to be available in the path. And you don't have to do this mental gymnastics either. So I just recommend that you play around, that you install KeePass XC using Homebrew, because this way you get access to KeePass XC CLI directly. Okay, and as a demo, if we run KeePass CLI like this, we can create a database. I'm just going to use the default values in here. And then we can tweak a lot of different settings. So for example, we can use the shiny new Chacha open source cipher, and we can use Argon2ID, the Argon2ID key derivation function. And since I'm on M4, we can really do a lot of iterations in a single second. Also, you can just tweak these settings to almost infinity. It's going to make your life miserable, and it's probably not going to deter any FBI state agents or anything, but suit yourself. And when we have to enter a password, I'm just going to use Hunter2 throughout this video. And yeah, and then we can just drop it on the desktop or something, and then you can add passwords to your heart's content. Like, we can add a new password, and we can just say this is my wallet key, and then we can generate your wallet passphrase using KeePass or using a different tool. And that's actually the password manager I use in everyday life, because it's open source, it's considered pretty secure, and I actually just keep my passwords database in Dropbox, or you can basically put it anywhere because the database is encrypted. So even if you just upload it to your GitHub repository, it's going to be mostly safe. Because like even if you have the database, it's going to take you a long time, even with quantum computers, to crack your database. So that's what we're going to use in this project. And we are also going to use this library called Go BIP39 to generate passphrases. And we are also going to use this library to read passwords in the terminal. Okay, so let's start by creating a directory. I'm going to call it wallet for now. And we can initialize a Git repository using go mod init github.com/moros/wallet. And I think we can commit git init git add dot git commit -m initial commit, and then jj git init collocate. Okay, great. And now we can write some code, and I think we can start by actually reading a passphrase. So in order to do this, main, I'm going to import this library, go get -u, this library, and then we can probably use this read password thing. Okay, so let's just say fmt print print. We are not going to use printf. Do we have a print? Okay, we do have a print. Okay, print enter a passphrase, and then we can read a password. So passphrase error equals term read password, and then we have to pass the standard input as a number. I think you can do it like stdin. No, we cannot. I think we have to use a library called syscall, and now it should work. So the difference between os stdin is that os stdin is a file descriptor, and this is just the number, and I think it has like a constant value. Go doc syscall stdin. Okay, so stdin is 0. These are standard numbers that are constant on all operating systems. And then let's handle errors, if any. And then we can try and print this passphrase. Or you know what, actually, let's print it with fmt. And go run hunter2. Okay, so two things we can see right off the bat. We did not get a new line even after we pressed enter. And also this passphrase was returned as a binary. So the first thing I'm going to do is I'm going to fmt println afterwards, and then I'm going to print this passphrase as a string. Okay, great. So now that we know how to read a password in the command line, we can do like a password confirmation. So I'm going to write a function called get passphrase. It's going to return a string and an error. And then we can write a helper function to to read a password from the command line. So read password. And it's also going to return a string and an error. So the first thing is okay, I'm just going to call it pw, and error equals term read password from syscall stdin. If error is not nil, fmt println, like so. If error is not nil, return empty string and error. Otherwise, return string password and nil. Okay, and with get passphrase, we're going to also need to ask for confirmation. So password1 error equals read password. If error is not nil, return empty string and error. And then password2 error equals read password as well. If error is not nil, return empty string and error. And then if password1 does not equal password2, return empty string and a new error saying password does not match confirmation. Otherwise, you can just return any of these because they should be equal and no error. So and this will contain a prompt actually. fmt print prompt, like so. Enter a password, confirm password. Okay, so passphrase error equals get passphrase. If error is not nil, log fatal f failed to read, create a passphrase for database, and we print the error, and otherwise we can print the passphrase. So let's try hunter2. Okay, password does not match confirmation. Okay, hunter2, hunter2. Okay, great. And also we need to add spaces in here. Okay, great. So we now have a function to create a passphrase. I think this is a good point to commit. And then the next thing we're going to have to do is we're going to create a KeePass CLI database. And in order to create a KeePass database, we need to locate the KeePass CLI binary. And let's see how to locate a binary. Go language. Okay, so we need to find a method to locate an executable, right? Do we have something like cmd? I think there was a package called cmd, go doc cmd, or a command. I think it is called cmd. Oh, or maybe it was called exec. Okay, great. So Okay, there is an exec look path prog. So binary equals exec look look path key pass xc CLI if errors is cmd error. Wait, no. Okay, so this returns an error. Okay, if error is not nil, log fatal error, and otherwise we can fmt println bin, and we can actually put this above the password prompt, so we don't have to create a password if there is no binary. So go run. So now we know that this is where the KeyPassXC CLI library binary is located. And we can later use it to create a command. Now, actually, I wanted to show you something. So when you create a DB using KeyPassXC CLI, DB create demo kdbx, I think you have to pass. Okay. So what happens is when you call KeyPassXC CLI DB create with the -p option, -p I think stands for password prompt, what's going to happen is that the command is going to ask you for a password, and we are going to have to pass this password to the command. And the way we can do this is we can create a helper function again, and we're going to create db, and we're going to pass the binary. We're going to pass the password, or I'm going to call it passphrase string, and then we'll pass the db path, and all of those are going to be strings, and it's going to return an error like so. So the first thing that's going to happen is we're going to create a command, exec command binary, and we're going to have to pass arguments. So the first argument is going to be db create, then we pass the db path, and we pass -p, and then we have to simulate that the password prompt. So what we can do is we can actually just say stdin equals bytes buffers, new buffer string, and in this buffer string we're going to pass a template string, and we're going to add the password separated by new lines, and the password you're going to pass it twice. So password is like this, password is like this. Then std out is going to be bytes. Var std out buffer like this, bytes buffer. We can just use the zero value of this, and then we assign cmd standard input equals our standard input, cmd standard output equals standard output. And what's happening? Bytes buffer does not implement I write to. Can you, okay. Good enough. CMD standard error equals this standard output, and then CMD run, and error equals if error is not nil, or we return the error, or also if the command was there like a status? What's going to be returned if it doesn't return? Okay. Okay, so it's going to be nil if there is no error. So we can just return the command run thing. Or yeah, if error is equals command run error is nil, return nil. No, sorry. You know what? I'm just going to assume this is log fatal error. Yeah, like this. We just return if there is an error, and then we do not need to print the database anymore, and we are going to just create a database in the local directory. So create db with the binary, and the db path is going to be wallet.kdbx, and then the passphrase is going to be passphrase we have just set. If there is an error, we will get this will get handled. Okay, so now I'm going to remove this demo and go run hunter2, and now we have a wallet.kbdx, and we can open it using this keep_as_xc thing. Okay, so we have an empty database, and we can use it to store a secret. I think it's pretty good at keeping secrets. So now we're going to have to generate a secret. And so when you handle Bitcoin wallets, you need entropy, and they say you can use 256 bits of entropy. That's going to generate 24 mnemonic words, and this is like the default size. Or you can also just generate 128 bits, and then it's going to be easier to remember your phrase. But for now, I'm just going to generate a 256-bit thing. And now that we have a wallet, we can try and add an entry. And the way you add an entry to a keep_as database is you use the command add. So you can say add, and you have to pass -p, which means password prompt, and then we pass the database path, and then we add an entry. So we can just call it test thing, and then we have to first pass the password to unlock this command, and then we can pass a new thing. I'm just going to type 1 2 3 4 5 6, and now if you open this wallet using keep_as_xc, we can see that this test thing has been added, and it's the 1, 2, 3, 5, 4, 5, 6 that we passed to it. So I'm going to write another helper function, and I'm going to call add entry to DB, and it's going to take the binary, the database path, the database passphrase, entry name, password, and all of these are strings, and they can only return this can return an error. And then we're going to do something similar to the first attempt. We're going to accept that we're going to pass the passphrase first, and then password. The password we are going to store later. And then we can, these things can be similar, except that we pass add db path -p, and then we pass entry name, like so. And then we can do this, the same thing basically, the same error handling. And now I'm going to delete this wallet KDBX thing. And I'm going to generate a seed. So var seed equals make byte slice 32 bytes. Number and error equals a rand read seed. Oh, sorry. If there was an error, we log the error and exit. And then we can generate a mnemonic from this entropy. I'm going to have to install this package, and the funny part is that it's hosted at pkg-go dev under the path github.com/tylersmith-go bib39, but when you click on this link, this repository does not exist anymore, and this package is only hosted on Golang repositories. Okay, I'm going to go get -u this package, and then we can generate a mnemonic equals bib39 mnemonic, new mnemonic, like so, and we pass the entropy, and then we can store the seed and the entropy in the, so this is a string, and this seed is a byte slice. So we're going to have to pass the we're going to encode the seed as base 64, and we're going to store the seed, the seed phrase in a different entry. So add entry to database. The binary is this, and then what's the second argument? Database path is a wallet.kdbx. We can store it in a constant later on. And the passphrase is this. Entry name is going to be wallet seed, and that's going to be base 64 encode, standard encoding, encode to string, seed, error, if error is not nil, log fatal error, and then we do the same with this add entry to DB, and we pass the wallet mnemonic, and we pass the mnemonic, like so. And again, if there was an error, we process it. And now, so there is no wallet in here, no wallet database in here. So I enter the password hunter2, and we now have a wallet database. I can open it with KeePassXC, and we now have two entries in this database. One is a 24-word mnemonic, and the other one is the seed encoded as base64. And now we can take this seed and try to import it into a wallet. So can we import wallet? Yes, we can. And do we really need to type all of this? So can we copy it maybe? Okay, we can, great. So the checksum is valid and we can import this wallet. And then we can specify if we want to, which type of wallet we want to import. And then we import it and we can just call it YouTube. And I'm going to use my very secure passphrase of hunter2. So now great, we now have some addresses and we can use them to receive payments, and then we can use this receive thing, and could go on about the way these wallets are derived, but I think I can call it a video because I want to do something more related to this wallet derivation in a later video. So if you enjoyed watching my Franken wallet, please consider giving this video a thumbs up, and if you really enjoyed it and want to see me ramble about, you want to listen to my diatribes, you can also consider subscribing to my channel. And the source code that we wrote in this video is going to be available on GitHub, and I will add a link to the repository in the description below. So thanks for watching, and I will see you in the next one.